All right, folks. Hello, this is Mr. Zaxt, come to you with your last math unit of the year. All right, how awesome. So, what we're going to do for this unit is called functions. So, we're going to start with today what is a function? Okay, a function is pretty much, think of it like a machine. Okay, this machine, it takes an input, which I've written here in red, and it gives you back an output. It's kind of like a trade off. Okay, if you put something into it, you're going to get something out of it. So think of like if you're baking cookies, maybe like your input would be all the ingredients, and your output is eventually a tray of cookies. Okay, so a popular example we have for an input and output for the function is an alphanumeric code. Now, what this function does is it takes in a number. Okay, so the number is the input, and what it gives you back is the output. All right. So for this function, we have some inputs here. They are 8, 5, 12, 12, and 15. Now what that means is the output is actually a letter of the alphabet, specifically what number of the alphabet that is. So our first input is 8. So what we're going to get back from this function is the 8th letter in the alphabet. So that letter's A, B, C, D, E, F, G, H. Okay, so if we input the number 8, this function gives us back the letter H as an output. Okay, so going to our next input, our input is 5, so the 5th letter of the alphabet is A, B, C, D, E. Okay, our next input is 12. So we go A, B, C, D, E, F, G, H, I, J, K, L. So when I input the number of 12, I get back the letter L. And our next one, well, don't have to, say the whole alphabet again because we already had an input of 12. And we know that we should get back the letter L. So there's another L. And my last input is 15, and the 15th letter of the alphabet is O. All right, so when we have this alphanumeric code of 8, 5, 12, 12, and 15, the output gives us the word hello. All right, so this is a popular function to use. All right, so the alphanumeric code is one example. I'm sure you could think of many others. So a function, before we go on to the next part, it has one input, and for that input, it gives you a unique output. All right, so what that means is, remember how we had these two 12s here, and they both gave us L. This would not be a function if my first 12 gave me the letter L, and my second 12 gave me the letter Q. All right, that just wouldn't make sense, right? Because the 12th letter of the alphabet is L. There is no other option. Okay, so that's why this is a function. If I were to input the same number and get two different answers or two different outputs, that would not be a function. Okay, so what we're going to do today, as far as math goes, we're going to see two ways that we can recognize a function. Of course, there are others, but these are going to be the two main ones. So we have a graph and we have a table. Okay, so what we're going to do is start with recognizing a function in a graph. Okay, so how do we recognize a function in a graph? Well, we do something called the vertical line test. Okay, so you've probably seen, at this point, you've probably mostly seen linear functions. Okay, so maybe functions that look like this, or maybe they go down. Maybe we've seen functions that are like a U shape, or maybe even like the letter V. Okay, maybe these are different functions that you've put on a coordinate plane before. What the vertical line test does is it tells us if something is or is not a function. What that means is if I can draw a vertical line through any of these red functions and it only hits that function one time, it is a function. If it ever hits it in more than one spot, it is not a function. So on my first red line, notice this is a positive slope just to reinforce that, okay? If I were to draw a vertical line here, notice how it only hits the line in one spot. Okay, well, that should have been a vertical line. Try that again. So right here, it hits this line in one spot. So as far as that vertical line goes, it is a function. Now, if I were to keep making more vertical lines, like this one, or this one, it does not matter where I draw the vertical line. Notice how it always is hitting in one spot. Okay, so it hits here, and it hits here. So that means this red line would be considered a function, because all of these lines are only hitting the red one in one spot. And all of these are actually functions, because no matter where I draw vertical lines, it's always going to hit these in one spot. All right, so I can keep drawing more examples, and you get the point. All right, well, that one's supposed to be... Yeah, there we go. All right, so it doesn't matter where I draw these vertical lines, all of these red functions are functions, because they only hit one spot. So I have some more examples down here below for you. So notice, again, we have an example of a linear function. Right here, we have a linear function. It only hits in this spot. Here we have a parabola. Okay, this is a word you're going to use a lot next year. This is like a U shape. No matter where you draw that vertical line, it's always going to hit in just one spot. Same here with this curve. Doesn't really have any rhyme or reason to it, but no matter where you draw the vertical line, it's going to hit that function in one spot. And the same with this picture on the bottom right. Okay, for your examples that are not functions, that means the vertical line is hitting in at least two spots, maybe more. Okay, so this is, again, it's like that parabola, like that U shape, but it's just tilted on its side. So notice when I draw a vertical line here, this line is actually x equals 5. Okay, when I input 5, I get two different answers. I get 2 and I get -2. Look at these coordinates, okay? They have the same input, but different outputs. That means this is not a function. Same thing with this circle, okay? At this line, the same input of 2 is being used, yet we're getting two different outputs. That's not a function. All right, so same thing goes for this graph here, and same thing goes for this really squiggly line, because when we draw this vertical line, it actually hits three different places. Okay, so I have the same input of -3, but I'm getting three different answers. So when we do some examples ourselves, are these functions, yes or no? So when I go to draw some vertical lines in here, my first squiggly shape here, let's draw let's see if I could draw a vertical line here. Okay, so like here, notice it only hits in one spot, right? It's hitting right about there. It's the best guess I can get, or I could pick a different spot. Maybe I pick this line right here. Again, it's only hitting one spot near the bottom. Or if I pick near the end, it's still only hitting in one spot. Okay, so it does not matter where I draw the vertical line. It is always going to hit this function in one spot. So yes, that is a function. Okay, I can do the same thing for this line. Notice this has a negative slope. Okay, so when I go to draw some vertical lines in here, ooh, that was a bad example. Okay, so like that's a vertical line. It's only hitting one spot. Again, there's vertical line. It's only hitting one spot. And I can draw vertical lines all the way down this line and only hit ever in one spot. So yes, this is a function. My last example is this circle. Okay, maybe I draw my vertical line here. And what do you notice when I draw that vertical line in? Well, it hits the circle at this point and at this point. So since this vertical line hits in two spots, it is not a function. Okay, vertical lines should only ever hit the graph in one spot to be a function, but in this case it hits twice, so it is not a function. All right, going on. That's how to get functions from a graph, but now we are going to get functions from a table. All right, so we talked about how functions take an input and they give you exactly one output. All right, if you put the same input in over and over and over again, you should always get the same output. So if I keep putting an input of 3, input 3, input 3, I should always get the same output back. So if the first output is 7, every output should be 7 when there's an input of 3. Okay, but if I change all the inputs, then it doesn't matter what my output is. So here we have an example of a function and one that is not a function. This one simply, you can tell it's a function because all of our inputs are different. Okay, so if all of your inputs are different, this column really doesn't matter. Okay, as long as all of your inputs are different, it is a function. Okay, if we did have, say, you see out -1, 0, 1, 2, 3, well, what if I input 3 again? Okay, in order for this to be a function, it would have to give the same output as the previous row. So since this input of 3 gives an output of 4, if I were to input 3 again, it would still have to give me an output of 4 every single time to be a function. Okay, why is the next one not a function? Well, notice that my input has a repeat. Okay, it repeats 4 twice. Okay, if their outputs were the same number, it would be a function. But notice that when I input 4, one time I get back 7. But another time when I input 4, I get back 14. So I'm putting in the same number, but I'm getting back 2 different answers. So this is not a function, okay? If this were graphed, it would not pass the vertical line test. So let's do some examples below. We're going to look for our inputs and see if any of them repeat. Okay, so for our first example, we're looking at our X column because X is always going to be our inputs. Y is always our outputs. Notice that all of these inputs are very different. Okay, so it does not matter what the Y column says. This is a function because none of these X values repeat. All right, look at my next one. Do any of these X values repeat? -8, -3, +3, +6, +9. They are all different inputs. So yes, this is a function. All right, we will go to our next table. Look at these inputs, -3, -2, 0, 0, 1. Well, we have repeating inputs right here, 0 and 0. Do they give us the same outputs? No, they do not. One gives us -1 and one gives us +10. The same input is giving us 2 different outputs, so this is not a function. All right, and going to the bottom here. Again, we are circling our inputs, our X values. Do any of these repeat? -4, -3, 1, 9, 10. None of them repeat, so automatically that's a function. Again, look at our X values for the next example. 4, 49, 81, 100, 100. Okay, so see, this input repeats. We have 2 100s. Are their outputs the same? Well, this one is -10. This is +10. Those are different outputs. So the same input gives us 2 different outputs. So this is not a function. And for our last example, we circle our x's, all our inputs. -2, -1, 7, 7, 9. Well, our 7's repeat. So now we got to ask, do we get the same output for those? No, we don't, right? One gives us -2, one gives us +3, so again, not a function. The same input gives us 2 different outputs. Okay, so you can identify a function from a table or from a graph. Okay, even though these are written in tables, right, you could write them as coordinates. Okay, so for my last box, I could write this as -2, 7, or I could write the next point as -1, 9. Sorry, this is supposed to be -1, 9. Let's fix that. -1, 9, and I could write the rest. Okay, and you should notice that X values are going to repeat and their Y values are different. So it's still not a function, no matter as you see it as a graph, a table, or just as coordinates.